Welcome to the deep dive. Today we're plunging into software configuration. It's often kind of murky, isn't it?
It really can be.
We're talking about all those dynamic settings, the variables that keep systems running smoothly. Or, well, sometimes not so smoothly.
Right, the ones that can bring things grinding to a halt if you're not careful.
Exactly. Like, think about managing variables for, I don't know, a new ML model.
Mhm.
Or maybe flipping kill switches, handling A/B testing configs. It's just constant
It
change.
really is. And that management, it can feel like a tangled web sometimes.
Yeah.
A lot of potential for error.
Yeah, that lack of structure, that's where the risk is, I think.
Absolutely. Because these aren't just small settings. They can control core features, affect loads of users.
So maintaining consistency, knowing why something changed, avoiding those unintended side effects, that's the challenge.
That's the core challenge, yeah.
Okay, so our mission today is to cut through some of that noise. We're doing a deep dive into protoconf, which sounds like a more modern way to handle this, inspired by Facebook's internal system, configurator, apparently.
That's right. It's positioned as a way to manage the whole configuration lifecycle.
Right. So we want to understand, what is protoconf really? How does it actually work? And crucially, when is it the right tool for the job?
Exactly. We've got some good source material covering its features, use cases, how it functions at a high level.
And it looks like there are some key benefits we'll be exploring, things like code review for config.
Yeah, that's a big one. Code review for configuration. Also, updates without service restarts.
Okay.
Having a really clear representation of your config and, importantly, automated validation.
Automated validation sounds good. Okay, let's dig in. First up, what is protoconf? The sources call it a configuration management framework,
Right.
not just a tool. What's the significance of calling it a framework?
Well, I think that framing highlights that it's meant to be a sort of comprehensive system, end to end. It's not just, a place to store key value pairs. It's about the whole process, how you define config, how it gets distributed.
So it has a purpose beyond just storage.
Definitely. Two main goals, really. First, the specification part, making config robust, easier to combine different parts, less error-prone, basically.
Robust, composable. Okay.
And second, the distribution side, getting that config out to your services quickly, reliably, and making sure it's highly available.
Fast, reliable, highly available. Got it. Those goals, robust, composable, less error-prone. They definitely sound appealing.
They target common pain points.
So now we know what it is, broadly speaking. Let's talk about why you'd use it. What problems does it actually solve in the real world?
Yeah, good question. Protoconf really shines in a few key areas. If you have lots of services or hosts and you need to update their configuration frequently, dynamically, that's a sweet spot.
Like the A/B testing example or feature flags?
Exactly. Or gradual rollouts. Anything where the config isn't static. Protoconf is built for that dynamic environment. It kind of changes how you think about deploying those changes.
Instead of a full redeploy, maybe.
Right. You move towards more controlled real-time adjustments via config rather than riskier code deployments for every little change.
Makes sense. The source material also talks about writing configuration with code. That sounds interesting. How does that work?
So it uses Starlark, which, as the source notes, is a dialect of Python.
Okay.
This means you can define your configuration using code logic, rather than just, say, massive JSON or YAML files, which can get unwieldy.
So like actual programming constructs in your config definition.
Yeah, exactly. Configuration is code. You can express dependencies, logic, things that are hard or impossible in plain static files. It helps with organization, reuse, makes complex configs more manageable.
Right. Instead of just a huge flat list of settings, you get structure, like actual code.
Precisely. Which, you'd hope, cuts down on typos and those copy-paste errors we all know and love.
Guilty as charged. So what else does this config as code approach give you?
Well, because it's code, you typically store it in version control,
Yeah.
right? Maybe alongside your application code.
Ah, okay. So you get history.
You get history, yeah. Full audit trail, who changed what when,
Yep.
clear accountability.
And presumably pull requests.
Exactly. That's a major benefit. You can use your standard code review workflow pull requests, peer reviews for your configuration changes.
Wow, okay. Treating config changes with the same rigor as code changes.
That's the idea. It shifts configuration from being this sort of hidden, potentially fragile thing to something that's collaboratively reviewed and vetted. Should dramatically improve reliability.
Code review for config.
Yeah.
Yeah, that feels like a significant step up. What about catching problems before they go live automation?
Yes, that's where the validation comes in. Protoconf uses Protobuf.
Protobuf, okay, the schema definition language.
Right. So you define a strict type schema, a blueprint for your configuration data. Protoconf automatically checks any changes against this schema.
So basic type checking, structure validation.
Exactly. But you can go further. You can write custom validation rules in Starlark, too.
Ah, so like business logic for your config?
Kinda, yeah. Enforcing specific invariants or constraints that your configuration must always meet. And then there's canary testing support, too.
Canary testing for config changes.
Yep. Roll out a change to a small subset first, check everything's okay, then go wider. Adds another safety layer for critical changes.
So it's a much safer, more controlled rollout process overall, more confidence.
That's the goal. Higher confidence, fewer surprises.
Now, the sources do mention some limits. When might protoconf not be the right choice?
Good point. It's not a silver bullet. One key thing is eventual consistency.
Meaning updates don't hit everywhere at the exact same microsecond.
Right. Updates propagate, but maybe not atomically across all services instantly. If you need absolute simultaneous updates everywhere, protoconf might not fit. Also, while updates are generally pretty quick, often within minutes, there's no hard SLA on propagation time. So if you need guaranteed millisecond level latency for config changes, you need something else.
What about config size or update frequency?
Generally, it's best for reasonably sized configurations. Very, very large or super deeply nested configs might become a performance concern, potentially. And it's not really built for extremely high-frequency updates like multiple times within a few minutes. The typical cycle is around every 5 minutes or perhaps less frequent.
Okay, so eventual consistency, no strict SLA on timing, best for reasonably sized configs, and not for hyper-frequent updates. That clarifies the boundaries.
Yeah, helps you choose the right tool for your specific needs.
Definitely. Okay, let's switch gears slightly and look at how this works for a service. How does an application actually get these updates? The source had a Python example.
Right, that Python snippet is a good illustration.
Let's walk through it.
Okay, so first step, naturally, is importing the libraries you need, gRPC for the communication.
gRPC, okay. The remote procedure call framework.
Yeah, efficient communication between services.
Yeah.
And you also import the Protobuf-generated code that defines the protoconf service structure. And crucially, your specific config schema. The example used myconfig.
So gRPC for talking, Protobuf for defining the data structure, like that blueprint we mentioned.
Exactly. Next, the code sets up a gRPC channel. Basically, a connection to the protoconf service. In the example, it's just localhost 0.4300.
Connecting to the server.
Then you create something called a protoconf service stub. You can think of that as like a client-side object that makes it easy to call the protoconf services methods. Hides the network stuff.
Got it. A client proxy. So communication channel established, how does it ask for the config?
This is the core part. It creates a config subscription request. Inside that request, it specifies the path it cares about.
The path, like an address for the config.
Yeah, exactly. The example used, my project, my config. It's like saying, I need the config stored at this location within protoconf. Then it calls the subscribe for config method using the stub, passing in that request. And the interesting thing here is, this method doesn't just return once.
It yields updates.
That's precisely.
Yeah.
It returns a stream. The service effectively says, tell me whenever the config at my project, my config changes, and protoconf pushes updates down that stream.
Ah, so it's a push model, not constant polling.
Right. Much more efficient, the service just listens on the stream.
Okay, so the service receives an update object through the stream. What then?
For each update it gets, the code needs to unpack the actual configuration data. The update contains the value, but it's in a generic protobuf format initially.
So you need to get it into your specific myconfig structure.
Exactly. That's what update.value.unpack config does. It takes the value from the update and populates the service's local config object, which is an instance of myconfig.
And config here is just a variable inside the running service.
Yes. And in the example, it just prints the updated config object to show it worked.
But the key point is that this config object is being updated while the service is running.
That's the crucial part.
No restart needed.
No restart needed. The application sees the new configuration values immediately, or as soon as it checks that config object again.
That really enables that dynamic reconfiguration benefit.
It does. It encourages you to design software differently, building applications that expect their configuration to change at runtime and can adapt gracefully.
And this source mentioned this isn't just for Python, right? Because of Protobuf and gRPC?
Correct, because it uses these language-agnostic technologies, Protobuf for the data definition, gRPC for transport. You can have Protoconf delivering configuration to services written in Java, Go, C++, AO, whatever supports gRPC and Protobuf.
Making it broadly applicable across different tech stacks.
Yep. Protobuf is the universal translator for the config data itself.
Very powerful. Okay, so let's try and wrap this up. To summarize our deep dive, ProtoConf offers this structured, code-first way to manage software configuration,
A framework approach.
bringing advantages like audit trails via version control,
Dynamic updates without service restarts.
and those important validation checks using protobus schemas and custom rules.
Right. Preventing errors proactively.
And it seems particularly useful in environments with lots of dynamic change, where you want that config as code rigor, and maybe you're managing config across many distributed services.
Exactly. It brings discipline and automation to an area that can often be, well, a bit chaotic and error-prone in software ops.
Okay, so here's a final thought for you, the listener, to mull over. If you start treating configuration like adaptable runtime code using a framework like ProtoConf, how does that fundamentally change how you might design and deploy software?
Yeah, what new kinds of resilience or adaptability does that unlock when config isn't just static data anymore, but something dynamic?
Something to think about. Thanks for diving deep with us today.